Hey, how you doing? My name's Elton and welcome to the show. So this week it's all about Istio. The theme this month is Service Mesh. If you've seen the previous episodes, ECS-M1 was all about the architecture, what a service mesh can do for you, how it takes control of the networking between your components. And then last week, ECS-M2, we looked at Linkerd. Linkerd is kind of the first service mesh that layer on all those features on top of your apps that are running in Kubernetes. This week we're looking at Istio. Istio is probably the best known service mesh and probably has the fullest feature set. And we're going to demo just the kind of core pieces of what you can do. There's an awful lot of Istio that I'm not going to show you. What I want to get you is give you a feel of how you can kind of model things in Istio, some of the features it gives you, and the resources that it layers on top of the ordinary Kubernetes model. So with the Kubernetes API, you model your application with services and deployments and pods and all that sort of stuff. What Istio gives you is some extra resources on top that let you configure the traffic management between your components. So we'll see how some of that stuff looks. So yeah, we're going to get straight into it. So a whole bunch of demos. If you're new to the show, hello, my name's Elton. I'm a Docker captain and a Microsoft MVP and a Pluralsight author and a Udemy author and a Manning Books author. This is my weekly show where I talk about all things containery, Docker, Kubernetes, ecosystem, patterns and practices. And this week is all about Istio. That's it for the talking head bit, the intro. I'm going to switch over to that camera there, and everything else will be demos. Before I do that, I need to pull down my green screen, so I'm going to run my little advert video, and I'll see you in about 20 seconds. You're watching Elton's Container Show with your host, that's me, Elton Stoneman. These shows are live, unscripted and unrehearsed, so if you like my style but you prefer something a little more polished, then you should check out my courses on Pluralsight. Pluralsight's an online training platform, and I've got tons of video courses on there that you're bound to find useful. And if you prefer to learn by reading, then you'll be interested in my books, Learn Docker in a Month of Lunches and Learn Kubernetes in a Month of Lunches, which are both published by Manning. And if you just want to see what I'm up to, then you can check out my blog. And now, back to the show. Okay, and here we are. So question straight away from Ashish, who says, can you use a service mesh with Docker Swarm? So the service meshes that I've been demonstrating, no, is the nice fast answer. When he's also asking about Windows, these things don't typically work on Windows if you're using Kubernetes either. So the reason why Linkerd and Istio work so well with Kubernetes is Kubernetes doesn't just run containers. It has this abstraction layer. It has this concept of a pod that wraps up your container, and there could be multiple containers in that pod that share the same network space. So what Istio and Linkerd do is they add a proxy pod, add a proxy container inside your pod, and that takes control of the traffic management. So it takes the network away from your application and it applies the rules that you configure centrally. Docker Swarm doesn't let you do that, so it just has containers that are kind of grouped in a service. You can run a service mesh on VMs on bare metal by running an agent, but there's nothing that kind of works nicely with Docker Swarm that I know of. I'm happy to be corrected. Okay, so everything I'm going to run through here, all the demos are up on GitHub. The only thing you need to follow along with me if you want to do this retrospectively is Docker Desktop or some other Kubernetes deployment. There's a bunch of links here at the start. So I'm going to just whip through what you can do with Istio here. I did a Pluralsight course, which is like 4 hours long, goes into a lot more detail about that stuff. My most highly rated course. So if you like the stuff I do on Pluralsight, check that out. There's a few other links here to the very first episode of this series where I talked about the architecture. There's the Istio documentation and a tool that we'll be using for load balancing. You can't really get away from the question of the CNCF with Istio. It was originally going to be donated as a CNCF project, and then Google kind of backed out of that. To some people, that's really important, and to other people, they just don't care. But you should be aware of the fact that Istio isn't part of a clear foundation in the way that Linkerd is. You might not be bothered about that, but you should be aware of it, and that link will give you IBM's take on the situation. Okay, so just like with Linkerd, Istio runs a control plane that sits inside Kubernetes. So it runs as standard Kubernetes resources, services and pods and stuff. But in order to manage that, because it's fairly complex, there's a separate command line, Istio command line, istiocutl. I've already installed that. You can install it on Windows with Chocolatey or with Mac or Linux just by downloading that script. So I've already got that, and that's going to talk just like the Linkerd command line does. Uses your Kubernetes, your kubectl context to talk to the Kubernetes cluster and deploy stuff. So we're going to get straight in and deploy Kubernetes on my Docker desktop machine. So I've got istiocutl. Let's make sure that it's all installed. So version tells me 1.9 is the latest version. It connects to Kubernetes as well, and it tells me that there are no pods running, so it knows that my Kubernetes cluster is completely clean. I haven't installed Istio yet. I'm going to run get nodes just to make sure I'm connected to the right Kubernetes cluster. Docker desktop, that looks good. So when I ran through the demos yesterday, I was accidentally connected to my blog, the Kubernetes cluster in Azure that runs my blog, and ended up deploying Istio and got very confused about why localhost wasn't working, but we're all good today. Okay, first thing I'm going to do is install Istio. So I can do what I did with Linkerd to generate the YAML and look at it, but Istio has this notion of profiles. So a profile can have one or more of the features of Istio enabled. So I'm going to use the demo profile and just install everything here. So it's going to install all this stuff. Good evening, Sivank. How you doing? So as before, I've already kind of run these commands through. So all the Docker images are pre-pulled, but the experience will be exactly the same when you run this yourself. It's just standard Docker images that are up on Docker Hub that are going to be running in Kubernetes. You get this nice little output that tells you all the pieces that are up and running there. We'll go through some of these things today, but not all of them. Okay, so we're going to move on and look what has actually been deployed by the command line. So if I look at my namespaces, I've got my default namespace as my standard kube system, but I've also got this Istio system namespace, and that's just been created 29 seconds ago. That's where all the Istio pieces live. Now, if you watch my Pluralsight course, which is a year or so old, or if you've used Istio in the past, it used to be, the control plane used to be a distributed system. There are lots of different components called Pilot and Mixer and Citadel, and you could see all those things. But as of Istio 1.5, they merged all that stuff together into one kind of monolithic control plane. And that's what we see here. So if I have a look at the things that are running in that namespace, there's not a whole ton of stuff. There's various replica sets and things. But the pods that I'm interested in, there's Istio D, which is the control plane. And then there's an Ingress Gateway and an Egress Gateway, which control traffic coming into the cluster and going out of the cluster. So those are the core things. As long as they're up and running, you've got your control plane there. Okay, so again, if you used Istio in the past, when you installed the demo profile, you used to install a whole bunch of other stuff. So one of the big reasons that people use a service mesh is for observability. And Istio in the demo profile used to install Prometheus and Grafana and Jaeger and Kiali and a bunch of other stuff. It doesn't do that anymore. It split those things out into separate deployments because typically you may already have your own instance of Prometheus that you want Istio to use, and having to manage all that stuff kind of gets a bit clunky. So they split that out into a notion of add-ons, and you can deploy your add-ons. I've just grabbed these YAML files from the Istio repo, and that's going to install those things that previously I would have got before. And just like with anything, a lot of these components create custom resources in Kubernetes, so new types of object that they can work with. And when you deploy all that stuff, the custom resource has to exist in the database before you can use it. And so sometimes you get this kind of race condition where it tells you that there are no resources for this kind. So when you see this kind of error, you just run your command again. That's the beauty of having a desired state approach that you get with Kubernetes. Every time you can just keep repeating your commands and you should get the same output every time. Okay, so that's all looking good. So now if I look at what's in Istio system, I'll see a whole bunch of other things. So I've got Jaeger, I've got Kiali, which is the front end that gives you a kind of service graph. I've got Prometheus in there. So a whole bunch of other things that are up and running, optional, but they give you the observability. And if you're just trying this stuff out, you really want to see those things so you can see what the service mesh gives you and where you're going to need to do work in your application model and in your application code in some cases to get the full benefit. So those are the things we're going to have running for our environment. And we can spin up the dashboard here. There are a bunch of services for those components, but they're all cluster IP services. They're only internally available. If you want to expose them, you can do a port forward, or you can change them to load balancer services. But the easiest thing is to use Istio Cuttle. The dashboard command will launch one of those dashboards for you. And this is Kiali. Kiali is really nice. There's not much to see there at the moment, but we'll use this as we go through. It knows about the namespaces. It knows about the applications that are in those namespaces and things like the workloads that show up the pods, the services that show the networking components, and any Istio objects you've got set up in there. So that's just a nice kind of way to see what's going on inside there. When we've deployed our application, we will see a live graph of the nodes in our distributed system and the traffic that's flowing between them, and a kind of high level view of how much traffic there is, and any early warning of things that are going to go wrong. Okay, so that's the first thing. So we've got Istio deployed. That's the control plane that's going to manage all of my network communication for me. It's going to propagate the rules to all of my pods when I create them, and the add-ons that give me the observability. But nothing running in my cluster yet. I'm not running my application. I can deploy my applications and not have them registered with the mesh. So when you're looking at bringing a new service meshed application onto your cluster, if you've got existing apps that aren't going to be part of the service mesh, that's fine. So I can have my existing applications and then just manually register the new components, or put them in a namespace and have them automatically registered. So any new components in that namespace will be picked up by Istio and have the proxy injected. So that's what I'm going to do. I've got my namespace here. So let's close my terminal a second. We can close this down and close that down. So my namespace here, I'm going to create my Widgetario app, which is the demo app I've been using for a couple of weeks. And the only thing about here is I've got this label. I've got a label for my own benefit, so I know this is to do with this particular episode. So when I delete my namespaces, I'll do them using that. And I've also got this Istio injection. Now this is a namespace label. So any workloads that get created in this namespace, any pods will have Istio automatically injected, which means they will have the sidecar container configured with all the proxy settings ready to control all the traffic through from the application container. Will all go through the proxy container. You can layer those labels. So if you want a particular deployment or a particular pod to not have the proxy automatically injected, you can override those labels. So you can have a kind of opt-in or an opt-out system depending on how you want to deploy it. I'm going to create my namespace with auto injection enabled. And that means when I deploy my application, everything will already kind of get straight onto the mesh. So nothing special here, just creating my namespace. And Istio Cuttle has got a few other useful commands. So as well as deploying your cluster and giving you access to the dashboard in a kind of temporary safe way, so you don't have to make them publicly available, there's a few nice little tools like Analyze, where I can take a folder full of Kubernetes YAML files, and I can tell Istio to have a look at those. I'm gonna deploy them to this namespace. Tell me if there's any problems with it before I go and do it. It's like static analysis for code. It's just going to validate my YAML files, look at the configuration of that particular namespace, and it will tell me whether there's any problems in there. And I've been through, and there are a couple of warnings that Istio likes to have the ports in your service to have a particular naming convention. If you don't do that, you'll get warnings here, but I've already fixed all those, so this is all looking good. So now I can deploy it. So you're going to use Istio Cuttle when you're kind of managing the control plane, or you want to do very Istio specific things, but all of the rest of your application operations and all of your app modeling, so mean standard Kubernetes YAML manifests, standard kubectl commands. So I'm going to go and deploy my application here. All the YAML files for this are all up in GitHub. There's nothing special about any of this stuff. So none of these components mention Istio at all. So I've got services and deployments. There are no Istio annotations or labels or anything like that, but they will all be registered with the service mesh because they're in that namespace. They're being deployed to my Widgetario namespace, which has the automatic injection enabled. So even though these are standard Kubernetes resources, because the namespace they live in is registered for Istio, they will all come on and be registered into my mesh. Okay, so let's have a look at these pods here. So I'll clear this down. What we'll see here is, so if you didn't see previous episodes, this Widgetario app, there's a website, there's a couple of backend services, there's a database. So each of those runs in a separate pod, and we can see that each pod has got more than one container running. So I've got 2 out of 2 containers. In the pod spec for each of these deployments, there's only one container. There's the application container. But because these are deployed inside that namespace, Istio has injected a second container, which is my proxy container. So Istio uses Envoy, which is a separate component for the proxy. And that's what Istio's job is, to take the higher level modeling of your traffic management rules and convert them into configuration for Envoy and set up your proxies for you. Okay, so they're all running, so that looks good. If I look at one of those pods, so I've got these various APIs. If I look at my stock API, I'll see there's a whole bunch of events here. I can see my Istio proxy container image being pulled. So that's the thing that's actually going to direct the traffic. My application container is completely transparent. It doesn't know that's happening, but the proxy container is owning the network space and applying whatever rules I set. And if I scroll all the way up here, I'll see a couple of interesting things. All the way up here, there's an init container. So first of all, when the pod starts up, this init container runs, it goes and fetches the configuration and sets up everything in the container environment, which is the file system, effectively, of the pod for other containers to share. And then down here, I've got my actual application image, which is my stock API here. So that's the only thing that I've defined. All this other stuff has been injected with a mutating admission webhook, and that's what the Istio control plane does. So when my pod's been surface has been created by the Kubernetes API, the webhook gets called and it injects all this other stuff into the spec. And down here, I will see my proxy image here. So there's my Istio proxy image up on Docker Hub, and all these arguments about how it's going to run and all this stuff down here. And way down, the last thing I'll point out here somewhere is there are various mounts inside here getting things like the Istio CA cert. So one of the big things about service mesh is they can secure and encrypt the communication between your components, which isn't super hard to do if you want to do that yourself. But the hard thing is managing your certs. So managing the certificates to make sure that you have a short-lived certificate. So if it gets someone gets a copy of it, then they can't do much with it for very long. Rotating those certificates, applying them, all that sort of stuff. The service mesh takes care of all that. So here I can see Istio's got its own certificate authority, and it will generate certs for everything else. So Moz says, can pods and namespaces with Istio enabled communicate with other namespaces which don't have Istio enabled? So by default, yes. We're going to see that in a demo, but by default, because services are kind of cluster-wide resources, in my Widgetario namespace, even though it's meshed, I can have other components calling into those services, but you can stop that as well. So Istio will let you do that by default as part of a kind of, gentle deployment of the service mesh. But if you don't want any other components calling your services, then you can have rules that enforce that, and we'll see that later on. Okay, how are we doing? We're doing 17 minutes, not too bad. Okay, so that's all the stuff that we see inside our pods, all taken care of by Istio, all taken care of by the control plane. I don't need to work with Istio Cuttle anymore, and I don't need to work with it from a modeling point of view. That's all going to be Kubernetes resources. But now that I've got everything up and running, if I open Kiali again, that's going to spin up my Kiali. Let's close this one down because it's all the same. And now, when it refreshes finally, hopefully, I've got Widgetario here. So here's my new namespace. If I go to the graph view, and I can open up my Widgetario namespace and look at this versioned app graph, there's nothing there right now because this is a live traffic view, and I'm not sending any traffic into my application. I can click this display idle nodes, and I get this kind of ugly collection of icons. These are the things that it knows about. The triangle is a service. The rounded square is a pod. So it knows about those things because they're registered with the mesh, but there's no traffic, so it can't see what's going on where. So now if I go and browse to my application, which is, I should have a link for it down here. Here it is. So it's the same rubbish demo application that you've seen lots of times before. So the website is a Go application. The two backends, one of them is Java. The other one is, I forgot what the other one is. No, the front end is .NET. The two backends are Java and Go. So, and then there's a database, which is Postgres. So in order to see these prices here, everything must have been talking together, so everything is working correctly. If I refresh this a few times just to send some traffic through, all of the communication in my components is going through Istio. So I'm already getting some of the features without having to do anything in my application, just with that flag in my namespace. If I go back to Kiali here, now I'm seeing what I would expect to see. So it doesn't know what the entry point is because Istio is not acting as an ingress for me. So the external traffic is coming into a load balancer service. Istio doesn't know about that part, but it knows from here on in. So it knows from the Widgetario web, there's an HTTP service that is sending to my pod, and from my pod, there's traffic going to the products API and the stock API. If I look at these things, I can get a rough idea of how many requests per second, what we're seeing down here. Requests per second successes, and a breakdown of things like 300 errors and 400 errors. So like really useful high-level overview of what's happening, especially useful if you've got a wide array of services and you're not really sure if all of them are being used. This will show you that they've got some kind of random pods out somewhere that are never being used, never being contacted. So maybe that service was just an experiment that never made it anywhere. Okay, so that's a nice high-level view. It'll go back to showing me nothing at all when the traffic stops. So later on, we'll spin up a load test to keep that graph running. So we can do that using what is a spin-off of Istio called Fortio. Fortio is a load testing tool. It's really simple. You just run it in a Docker container. What it does is you give it an IP address or a URL rather to connect to. I'm going to run it in a container. I'm going to ask it to talk to the Docker host on port 8010. So when I'm on my machine, because I'm using Docker desktop, I can use localhost and get to my Kubernetes application. If I was running inside a container, I could use the IP address of my machine, but Docker does that for me. So I'm saying go to my host machine on port 8010, which is where you'll find my app. And then this stuff here is saying how much load to throw in, like 32 concurrent calls with a 25 per second for 30 minutes. So just nice and kind of easy, and I'll just sit there and throw a load of load into my application. So I'm going to start that in a separate terminal here. And that'll just kick off and start throwing things in, and it'll take a little while to filter through. So what's actually happening here is that when the calls are being made through my components, the network traffic is happening, and then kind of out of band, all the reporting side of it is happening. So typically, Istio is gonna collect traffic using Prometheus, and then it surfaces it in different ways. So the Kiali stats and the Grafana stats that we see later on are all coming from that same Prometheus data store. So there's a very short lag, so you just need to fill up the time a little bit with a bit of talk, and then we should be able to see some data coming through. So this is refreshing, showing me the data for the last minute. It's going to refresh every 15 seconds. Not a huge amount there right now, but here we are. Here's a spike of the traffic, which we can see right here. So it's kind of 0, 0, 0, and then suddenly a big spike. And if we go and look at these things, we can see, say, for the products API, it's getting something like 18 requests per second over that time period, whereas my stock API's got something like 60 requests per second. So the way this app works is that you hit the website, it makes one call to the product service and multiple calls to the stock service, and we can see that at a very high level inside here. You can display various other little things. It's just a high level overview, Kiali, but it's kind of useful. So it shows you things like, what am I looking for? I can include the versions, so any labels that I apply to say, if I'm doing a canary deployment, I can show those labels inside there. And I can also display the thing I want to see here is a request distribution here. So I can see that 100% of my traffic came from this web service, the load balancer service, into this pod here. And then of all the traffic that's going out of my pod, 25% of it went to my products API and 75% to my stock API. So I can just get a feel of where that traffic's going. Maybe like I'm not expecting the stock API to be hit so hard. And so I can see very, very clearly what's happening here. Okay, so we're going to leave all that stuff running for a second, and we're going to go and look at how we do security. So typically when people are demoing things like Istio, the first thing they'll show you is a canary deployment, because it's a really nice way of managing traffic split between version 1 and version 2 of your application. But actually, one of the best things that you get from a service mesh, we saw with Linkerd last week, is this kind of mutual TLS, the encryption between your components that you get kind of for free. So my web API, my website is talking to my backend REST APIs just using HTTP. So inside the code for the service, it's just listing on HTTP. Inside the code for the client, it's just sending a plain HTTP request. But because Istio owns both parts of the communication, so there's a proxy pod going from my web client, proxy container in the pod from my web client, sending the traffic out. There's a proxy container in the pod from my backend service that's receiving the traffic. So because Istio owns both ends, it can upgrade that conversation from HTTP to HTTPS, and it can apply mutual TLS. So it can give me encryption for the traffic, but also it can do things like authorization. So we can put in authorization rules based on the service identity, the identity of the pod that's running the client call. So we've already got mutual TLS because you can't get that for free. I'm going to close Kiali down here, so we can see what we're doing next. But what you can do, so the mutual TLS you get for free. So Istio is going to create those certificates for you, encrypt the traffic. That's all just happening right now. It's done in a graceful way. So by default it says that if the communication is between two components that are on the mesh, then we will apply mutual TLS. But if it's a client that's not on the mesh trying to consume a service, then we won't enforce HTTPS. So Moz answering part of your question there. So it will allow a plain text call into a service that's on the mesh, because if it didn't do that by default, then you couldn't have any other components talking, because they wouldn't be able to take part in that mutual TLS conversation. But the other thing you can do, you can enforce that even more by having an authorization rule. So inside my application, I've got my various different components, and nothing external needs to be able to talk to those. But in a standard Kubernetes deployment, they can, because services span the entire cluster. what I'm going to do is I'm going to apply a bunch of authorization rules using Istio to say only this component can make network requests to that component. And again, I'm not going to put this in code. It's not going to be any change to the config of my application. I won't have to roll out an update to my pods. It's going to be purely a change to my Istio configuration. So the way that Istio does this is by using the service account that the pod is running under as the identity. So it defers authentication to Kubernetes, and it says you're going to run in the context of a service account. I will trust that identity, and I will use that identity as the basis for my authorization rules to say who can do what. So it sounds more complicated than it is. So the only change I've got here is because I didn't do this for when I did my first deployment, is that I'm explicitly creating and applying a service account for each of my components. So right now they're all using the default service account for the namespace, but I'm creating a new service account for each component and applying it. So my website here is going to have this Widgetario web service account that I'm creating in the YAML up here. And in that folder, in this demo3 folder, I've got similar things for each component. So the stock API will have its own service account. So will the database. So will the products API. And that's just I would have done that in my original deployment, but I want to show you the differences between what you need to do to get this authorization working. So I'm going to apply this change. And right now, it's not going to really do anything. It's going to create those service accounts. It's going to recreate my pods that are now using that service account identity. If I browse back to my app, everything's going to just keep on working. It's new pods, so there'll be a slight kind of warm-up delay before it's running again. But everything still works. Istio now knows the identity between the client and the server for each of my network calls. I can take advantage of that to apply my rules to stop anything that isn't part of this application domain making the calls that I don't want it to make. So if you're coming from a background where you have these network boundaries to have, my different tiers, my back end and my middle end and my front end, you can kind of mimic that using these authorization rules. So let's see how they look. Let's close my terminal. And what I'm going to do first of all is deploy a kind of default deny policy. So this is a custom Istio resource, so an Istio CRD called an authorization policy. You can apply them at different levels. I'm applying this at my namespace, and the spec is empty, which basically means deny. So if you deploy an empty spec, it's going to be deny any traffic that's going anywhere in your cluster. So when I deploy this, my app's going to break because nothing can talk to each other anymore. So let's open this up, clear everything down. I'm going to apply my deny all authorization policy and give it a second or two to propagate. That if you think about what's happening here, I'm not changing my pod definition. I'm not changing the proxy containers that are running. What's happening is the proxy containers have got a conversation with the control plane to get the latest configuration. And there's a very small delay in there. It's very small because it's cached for performance reasons. So it'll take a moment or two for that policy to take effect. But if I try and curl my application now, I'm going to get an access denied. And if I go back to, I've got my, oh no, I'm still running that. That's cool. I thought I was still running 40, but I'm not, so that's fine. So I've got an access denied. So now I can't even send traffic into my web application. So the very first part of my chain, even though I've got a load balancer service that's happily trying to send traffic in, it's being blocked by my Istio rule that's saying you're not allowed to send traffic to this pod because everything has been locked down. So now what I'll do is I'll gradually add back in the authorization that I want to have. So for the website, I'm going to allow anything to make a GET request. So this is the authorization policy with more detail applied. So the first authorization was a blanket deny within that namespace. This is now saying within the namespace Widgetario, have a label selector. So any pods that match the app label with the value web, this is where that rule will apply. This is the target for the rule. And anyone who's trying to make a call to that pod, I'm going to allow them to make any GET calls, any HTTP GET calls. So Istio understands network protocol, so it understands HTTP traffic and gRPC. You can also apply rules for TCP, but for gRPC and HTTP, you can go down to a lot more fine-grained. So you can say, this particular operation for this particular endpoint can be allowed. I'm saying allow any gets from anything from my website. Now for my backend API, my backend services, they've got more control that I want to apply because only the website should be talking to those things. Those are not kind of generically available. They're not customer facing REST APIs. So again, I've got an Istio authorization policy. It's going to apply at this namespace, and the selector is going to pick my stock API. So that backend Go service that's sending the stock information. Again, like I'm allowing operations to get any HTTP GET calls will be allowed, but only if the principal is this one. So let me expand this a little bit. So I'm only allowing traffic from this source. So that means, that the target is my Go application, but it's only going to allow traffic from a known source. And the known source is where this is the principal. And this is how Istio represents my service account. So within my cluster, within the namespace called Widgetario, there's a service account called Widgetario Web. And that is the identity that is going to be allowed access to my stock API. And that's the service account identity that my web component is running under. So that's how I'm getting my authorization. Istio is devolving to Kubernetes for identity. And when it gets the principal is coming through as this service account, it trusts that that's true because Kubernetes does that for it. And then I'm applying my authorization rules. Very similar thing here for the products API, which again should only be allowed from the website. So the target is my products API, but the principal is the same. It's my Widgetario web service account. So that's the initial website talking to the two APIs. And then for the database, slightly different because I'm allowing, so same deal in that namespace where the app is products DB. So that's my Postgres database. That should only be allowed access from the backend APIs. So those are the two principles that my services run under. So again, it's the Widgetario namespace and the service accounts for the stock component and the products component. So when those components try and reach the database, those are the identities they'll present to Istio, and then Istio will apply this rule and it will allow them. And what it's going to allow them to do is make TCP calls to this port. So that's the default Postgres port. This isn't an HTTP conversation, so I can't explicitly allow, get and delete and head and post. But it's TCP, so I'm just going to allow all traffic through to my Postgres server. So now in between my stock API, my products API, and my backend database, all the communication is encrypted, and I've got those authorization layers so other components can't talk to my database. So even though my database is just listening on plain unencrypted traffic, actually the conversation that's happening is all encrypted for me. Okay, so standard kind of Kubernetes things, they're custom resources, but I work with them in the same way as I would any other Kubernetes resource. So let's clear the screen. I'm going to apply all of those rules now. So those are the various different authorizations that's really modeling that kind of network split to say we shouldn't be allowing traffic from A to B willy-nilly. We're going to have fine-grained rules. You can achieve something similar with Kubernetes network policy, but the problem with network policy is that it's a standard Kubernetes resource. So you don't need Istio for it, but not every cluster supports network policy. So your network plugin that your cluster is created with may or may not support policy, and the only way you know if your cluster supports network policy is if you created your network with cluster with network policy support. There's no real way to try it. So if you deploy a network policy resource in a cluster that doesn't support it, it just says, yeah, that's fine, I've created it for you, but none of the rules get applied. So it's kind of a strange part of the Kubernetes API. Whereas with Istio, if I try to deploy this without Istio, it would all fail. And if I'm deploying it with Istio, then I know my rules will get enforced. So now if I try and curl my site, everything's up and running. So I don't get that RBAC issue that wasn't allowing me to connect to my website. And the website is talking to all the backends. And again, these prices come from the database. So my services have got access to the backend database. So it's all looking really good. Does Istio support IP block? I don't know. I don't know the level of details that it goes down to. But if you think about the addressability, it's really in terms of the identity that you present. So what I've shown you with these authorization here is a service to service authorization flow. You can also do end user authorization. So you could pass a JWT token along to all of your calls, and you can have your Istio rules looking inside that JWT to say this particular service should only be allowed if the end user has this particular claim in their token. So there are different levels of how you can apply your security. Okay, so let's scroll down here, see how we're getting on. There's lots more to demo. So I'm going to show you the fact that other things now cannot talk to my API. So inside here, I've got a really basic pod. It's not even got a deployment or anything. It's just running like it's just a debug kind of pod where I can use to connect. But it's got this flag set, so it's not going to mount any service account token. So by default, Kubernetes will provide the service account of the namespace that it's running in for each pod. You can turn that off. It's a kind of nice security feature to turn off if your app doesn't use the Kubernetes API. So just turn that off. And that means that this pod won't have any identity. If it did have an identity, it would be for the default namespace, so it wouldn't be allowed to talk to my services anyway that are in my Widgetario namespace. But now I don't even have an ID, so my authorization will block that. So now if I go and deploy this, we'll see what happens. So I'll deploy my sleep pod, and I will exec into that pod. And in this pod, I'm in the default namespace, separate namespace, but because services are cluster-wide, I can do an NS lookup from my stock API in my Widgetario namespace, and I'll get the IP address of the service. So, it looks like I can contact it, but if I try and do an actual HTTP call using wget, you'll see I get a 403 forbidden error. I get an actual HTTP response, a 403 response that looks like I'm not authorized to make the call. It looks like my service is providing that, but it's not. My service knows nothing about. It doesn't have any authentication or authorization. So this is being applied at the proxy level by my rules that I set up with Istio. So super high value way to layer on security to your application. Okay, so let's leave this now. So the next thing we're going to look at is traffic management. So I'm not whipping through this really quickly, but if you look at what you can do with Istio, I'm trying to pick out some of the main features that will hopefully kind of get you interested into looking further. That security side of it is really important, and the thing I'm trying to get across is that it's really actually quite easy. So to implement fairly detailed controls over all of your components. If you think about a distributed application, you should know what the rules are. So, typically you don't just have everything talking to everything else. You should be able to model those rules fairly easily. And as long as everything has its own service account, then you're just going to have those authorization policies saying A can do this and B can do this and everything else can't do it. So it's a really nice way to model your security. Okay, let's close this down. So the next thing we're going to look at is traffic management. So the big features that you get with the service mesh, you get the security, you get the observability, and you get this kind of traffic control thing. What we looked at with Linkerd last week is being able to split the traffic based on things like, canary deployments that you want to do. With Linkerd, it was taking the service mesh interface approach where you have multiple Kubernetes services, capital S services in Kubernetes, and you define some rules to shift traffic between them. Istio takes a different approach. Istio has its own custom resources that split the modeling of the traffic. So on the one hand, there's this destination rule, which defines the potential targets for your communication. And then there's this virtual service that actually specifies the rules of which of the targets in the destination rule you're actually going to send the traffic to. We'll see some of those in a second. But the point of it is that you don't need to model your application in a different way. I don't need to have multiple Kubernetes services. I can stick with the services that I've currently got and then layer on the extra functionality that I want using those Istio resources. Okay, so let's have a look. What we're going to do is deploy a new version of my products API that returns the prices for my components. And the new version is just going to make the products more expensive. So really simple to do that. What I've got here is just a deployment. The big difference is that I've got a version label inside my pod spec. So it's a separate deployment. It's not an upgrade to the existing one. It's matching based on the products API label and the version v2. And I've got I've still got a Linkerd annotation in there, so I should take that out. But it's just going to get ignored because I don't have Linkerd deployed in the cluster this week. Okay, and what I've got inside here, it's the same image, but it's got this configuration flag to increase the prices. So nothing to do with Istio, nothing to do with services, just a separate pod that's going to sit there and able to receive traffic. And now I'm also going to deploy my Istio components. So this is the destination rule. The destination rule is really it's a kind of client-side thing. So when the proxy makes an external call, it's going to say, where are my options for sending these things? It's a custom Istio thing. Again, it's namespace. So I'm saying, this is to do with the products API. It lives in the Widgetario namespace, and then you specify the host, the actual either the fully qualified domain name or the short domain name of the target that you're actually configuring here. So any requests that go into the products API in the Widgetario namespace, these are the actual potential targets that we're going to have. So two things I'm going to apply here. So first thing, I'm saying that Istio mutual is the TLS requirement. So we're going to have mutual TLS, and what that means is that Istio is going to manage the certificates for us. You can provide your own certificate authority, and then you can configure Istio to use that, but we're saying use the built-in stuff. She's asking about console. I'll come to your question at the end. And then the other thing I've got here is my subsets. So I'm saying there are two potential destinations for the traffic here. Never mind the Kubernetes service. This is working at the pod level. So I'm saying I've got two subsets. My version 1 subset is any pods that I've got the version 1 label, and my version 2 subset is any pods that have got the version 2 label. So so Istio is able to direct the traffic. These are the potential destinations for any requests that are coming into my products API. Good morning, Peter. Okay, so let's close this down. And the last one is my virtual service. So the destination rule is the potential target, and your virtual service says where we're actually going to send the traffic. So my virtual service, again, I'm specifying the host, which is the destination, the DNS name where my rules are going to apply. And I'm saying here for all HTTP traffic, again, Istio is aware of different protocols and they can work with them in different ways. I'm saying any requests that come into my products API, yes, we are going to send them to the products API, but we're going to send them to subset version 1. So that means any requests that come into that Kubernetes service, they're actually going to be sent to a subset of all of the pods that are available in that service. And the subset is being defined as anything with the pods with the label app version 1. So that's what Istio is directing my traffic. I'm not changing my ordinary Kubernetes modeling here. Okay, so let's go and see how this looks. So I'm going to deploy my products API folder. That's all the things we've just looked at. So my new deployment with the higher prices, my destination rule, and my virtual service. If I look at the pods now that are running my products API, I'll see there are 2 pods. My original one that's been running for 14 minutes, I've got my IP address there, 8.91, and my new one that's just started up, and that's 8.95. Now, my Kubernetes service, my product API service, is only using the app label, the products API label. So in theory, if I was to look at my endpoints here, I'm going to see both of those pods in there. So if I was just using Kubernetes networking, it would load balance between my version 1 and my version 2, because that's how the service works in Kubernetes. It's the label selector is saying both of those pods are potential targets. Those are my endpoints. I'm going to load balance between them. But that's not going to happen because Istio is taking care of the traffic for me. And because I've set my virtual service to only use the V1 label, it's going to ignore my new pod and just send all the traffic to the old pod. So I'm going to browse to my application here and refresh a few times. All the prices are the same, so they're my ordinary. It's only my V1 API that's responding with those prices. If I had any responses from the V2 API, then I would see the higher price coming through. Okay, so that's the kind of basis to get everything up and running. So the other thing to think about here is you can gradually implement these traffic management features, and the end result is exactly what it was before you made your deployment. So I'm sending everything to my version 1, but now I've got the structure in place, so I can do my traffic split and send some traffic to my new application version. So let's close this down and have a look at what we're doing here. So to do a traffic shift for like a canary deployment, the only change I'm going to make is to my virtual service. So the virtual service is where I'm defining the actual rules that where the traffic's going to get sent and how it gets managed by Istio. So what I'm saying here's that host again, that same products API host. I've got a split here for my route. So for any HTTP request that comes in, 75% will go to that same host with the subset V1. So most of my traffic will go to my existing deployment, and then 25% will go to my subset V2. Now you can have all sorts of rules inside here to match on the content of the HTTP traffic that's coming through. So because it's HTTP aware, it can look at the headers, and I can have different rules for different features coming in depending on the HTTP header content. So different users. If I've got some kind of header that enables me to identify a group of users, I can send them to a different endpoint just by using the rules inside here. But this is a global rule, so it's just going to send 75% of traffic to my version 1 and the other 25 to version 2. So we'll clear this down and go and apply this. So the only thing I'm changing is that virtual service. My pods, my version 1 pod, my version 2 pod, they're still there. They're still running the same way. My Kubernetes service is still there. My clients are still all running. If I go and browse to my application now, what I'll see is mostly I get my version 1 prices, but every now and then, there we are, I've got a version 2 price. It's just a bigger number. So that's come from my version 2 API. And what I'll see is that the more traffic I throw at it, the more accurate the percentages will be to what I target. So I should see like one in 4 requests will come with the higher prices. And I kind of vaguely see that. Okay, cool. So that's working exactly as expected. And of course, you can kind of roll that stuff out and see and gradually increase the details, the numbers of the split. And so my 50-50 split here, all I've done is change the weights, and I can apply that and send 50% of my traffic to the new API and keep the other 50% to the old API. And that's how you do your canary deployment. And you use your observability to make sure that everything is working as expected with the small amount of traffic that you send to the new destination. And I've got, like, I'm doing 25% here, but you can do 0.01% and just send a tiny amount of traffic on a hugely popular live application to a new component, verify that it's working correctly, and then very, very gradually roll out your canary deployment there. Okay, and if I go back to my terminal here and I repeat my docker run command to send a bunch of traffic through, that's all looking good. So now if I go back to Kiali, which will require another window, I know Istio is still going, cool. So if I open Kiali again here and refresh, what we'll see is it's kind of difficult to read, but now my traffic split is being shown inside the dashboard here. So let's try and zoom in a little bit. So inside here, I can see that all for my Widgetario web, all the traffic's going, 100% traffic's going to my web component. For the stock API, I haven't changed that, so all the traffic's going to my stock API. But for the products API, I can see there's a V1 and V2 split, and I can see the actual split that's happening here. So the requested split I've got in is 75-25. My actual split is 74.2 to 25.8. So I can see that traffic coming through. I can look at the response times here. So, maybe my new service isn't responding as well. I get that really quick feedback from a really clear visual model of the live traffic in my application. Okay, so let's stop this because that's going to just keep on hammering traffic going through. And the last thing I'll show you with the traffic management side of things is that you can do fault injection. So remember, Istio owns that communication between my components, so it can do kind of whatever it wants. If you want to do some chaos engineering, or if you want to do some testing to make sure that your application behaves correctly if some of its components aren't available, then you can do that with, I am reading your questions, but I'm going to get my demo done before I answer you. You can do that with the same mechanism with the destination rules and the virtual services. So I'm going to inject some faults coming from my stock API. So to do that, first of all, I have to have my destination rule to define what the targets are for the stock API. This is saying where the host is this stock API domain name. I've got one subset in there, which is my version 1 subset. I don't have any labels for my application here. So if you don't deploy your pods with any version labels, you're kind of limited, but you can still work like this. So I'm saying there's only one subset. Everything's going to go to that subset. I've got my virtual service inside here. And again, that's sending everything from my stock API to the stock API subset V1. So this is the structure that's going to enable me to put in the rules to govern the traffic. And then when I go ahead and deploy my fault injection, I'm going to change my virtual service. So that virtual service that says when the request is for my stock API, I'm going to send everything to my subset V1, but I'm going to inject this fault, and for 20% of calls, I'm going to return an HTTP 503. And it's a real 503. It's not like it's not something you're doing in code to try to simulate a 503. It's a genuine HTTP 503 response coming from the mesh. Okay, so let's go and deploy that. And I'm going to clear this down. And again, same thing. First of all, I can deploy my stock API components, which is just the structure of the modeling for my traffic management, my destination rule, and my service. Nothing's changed right now, but if I go ahead and deploy my my fault injection here, so that's going to change my virtual service configuration and add that fault to some of my calls when I push them through. And then I can test my application and just see how well it handles the fact that it can't reach all of its backend services. So I'll do this a few times. Every now and then I'll get a response that doesn't show me anything useful, and that tells me my app doesn't work very well. If I look at the logs for the web component, it will show me the problem here. I'll get a ton of error logs, and the error logs are saying something like, I'll get my error log here that's saying service unavailable. So that's my 503 response. So I can see how my component actually behaves if an upstream component fails at a network level. I can include any kind of status that I want here, any failure status, and just verify that my app does what it should. In this case, my web component returns a 404, which is kind of weird. So I need to go and look into that and see what the problem was. And the other thing I can do with fault injection, if I don't want to go to all the way of aborting the call, is I can put in a delay. So if I've got a delay here I haven't actually got my link in here. So let's open that up. There's my stock API, fault injection, delay. Same structure. So I'm saying, here's my virtual service. Here's where the destination host is my stock API. You're going to send it for real to the stock API version 1, but I'm replacing my 503 fault with a delay of 1.5 seconds. That's going to apply to 70.1% of all incoming calls. So when my website's making these calls to the stock API, 70% of them will slow down. They'll have a fixed delay of 1.5 seconds added, and that's going to apply to at the network level. So Istio will just stop, wait for 1.5 seconds, and then pass the request on to the service. Okay, so let's see how that looks, see if my app behaves any better. Let's close all these things down because things are getting out of control. Let's close that. Okay, so now I'll employ my delay here. Another type of fault, just a different way of configuring it. And now if I go to my local host and see what the app does, this time I should find that it actually does work. Where's it gone? There we are. If I refresh this, it should just take more time because most of my calls are going to be delayed. Remember, the website makes multiple calls to the stock API, so almost certainly one of them will hit that fault. And I can see that the website works, but it's taking a little while to come through. So again, I'm controlling that at the virtual service definition level. No weird configuration in my service, so I can inject a false delay. I'm doing all that on my service mesh configuration. Okay, so last thing, and then I'll look at your questions. So we can also use Istio as an Ingress Gateway. So I said right at the beginning when I looked at Kiali that my internal web component, it had that question mark. I didn't know where the traffic came from. Istio can be your Ingress Gateway, so you can apply those type of rules to your entry point for your application. So your website, I can do my fault injection, I can do my authorization at that level too, and register the incoming traffic effectively with my Istio service mesh and apply those same sets of rules. I won't demo that, but there's a link here so you can kind of follow along with all that stuff. The last thing I will show you is the observability piece. So I'm going to run my Fortio container again, this time with a bigger timeout because I know that I've got my delay being applied by Istio. So let's clear this down, run my Docker container, sending a whole bunch of traffic into my application, and then we're going to switch to a different command here. I've still got Kiali running. So if I look at Kiali now, and let's try and zoom in a little bit here. The thing that I'm interested in is my stock API. So what I'm seeing here is I should see overall the amount of time for my calls. So I'm still getting 100% success, so everything's still working correctly, but it should be taking longer to run through. And I can go, if I look at my applications here, I can drill down from my top level, is my website, going into my stock API. I can see the traffic that's coming through here, and I can look at the metrics. That will take me off to see these kind of useful graphs that tell me exactly what's happening here. So my request duration is kind of peaking at kind of multiple milliseconds. This is the number of operations per second that are coming through. Request size, all the useful stuff you need to drill down to work out what's happening with your app. Okay, so that's Kiali, gives me that kind of top level stuff. Then I've also got Grafana running. So if I kill my Kiali dashboard, if you just run Istio Dashboard, let's clear the screen so you can see what's going on. Then it shows you all the things that are available. So I've got Envoy, Grafana, Jaeger, Kiali, Prometheus, all the things that it knows about, that it gives me the option to see what's going on. Let's open up Grafana. We get some quite interesting low level stuff there. Because this is a temporary kind of a portal opening up from using my command line. There's no usernames or passwords or anything. I can just get straight in there. So if I look at my Istio dashboards, if I look at the mesh, it will tell me the high level of all the traffic that's going through the mesh, what's happening where. Here's my latency, which I don't really see very easily in Kiali, but I can see here my products API is responding within kind of 3 milliseconds, but my average response time latency for my stock API is 1.5 milliseconds because of the delay that I put in there. If I go and check, what was the other one I wanted to show you? The control plane and the service dashboard. So if I look at my Istio folder, the control plane here tells you how hard the bits of Istio themselves are working. So, kind of standard Prometheus dashboard showing me memory and CPU and what's going on inside my components. And these are all the drill down for the different bits of Istio that are running inside Istio D. And then if I look at the service dashboard, which is this one here, this is the thing that tells me, no, not you. Let's go back here. Oh, look at that. I've clicked on new dashboard. This is the bit that if you were watching my Pluralsight course, I would cut this out so you wouldn't have to watch me struggling to try and find the bit that I'm looking for. So if I look at, see, I've done it again. Let's go back to my dashboard, service dashboard. Stop clicking on that bit inside here somewhere. If I look at my stock API or my product API, here we go. So I see the client request duration, I get my service success rates, all that sort of stuff. If I drill down to the next level, this is the bit I was interested in. I get these little padlocks telling me that it's mutual TLS. So that was where I was trying to get to. It's telling me that the communication from my website to my product API is mutual TLS. So it's secured and I've got my certificate being provided both sides. Okay, cool. So there are a few other things you can do. The last thing I'm going to show you is Jaeger. So we've talked about this before when I talked about distributed tracing as part of the monitoring series that I did. Jaeger is going to do that distributed tracing, so it can tell me about, my website made these 2 calls, and it can chain them all together and show me what's happening. To do that, my application code needs to help Jaeger piece things together. And my application doesn't do that. So all I've got inside Jaeger here, I've got all of my components, my stock API, my web, and my products API. The traces are coming through. So again, they're being collected by Istio. I haven't got any Jaeger code inside my applications. It's all happening at the service mesh level. So it's collecting that information, sending the traces to Jaeger. But what I don't see is I don't see the kind of the entire transaction. So I can see the call that was made here to my stock API from the web component, but I don't see that as part of a wider transaction, which would include the web component, the products API, multiple calls to the stock API. So I can only see the pieces because I'm not including those HTTP headers. If you don't know what I'm talking about, then check out the ECS-M1 episode where I talked about propagating HTTP headers. And in distributed tracing, that's how Jaeger understands that this trace is related to that trace and related to that trace. It's kind of like a correlation ID that links those things together. I don't have that code, so I don't get that benefit. I would have to go in and add that to my application source if I wanted to see that stuff. Okay, so let's have a look at some of these questions here. So Moz says, share the repo URL. Absolutely. So what I've got in here, let me open this here. That's where you're going to find it. So all of the episodes are up on 6sides/ECS on my GitHub repo, and it's broken down into episodes, and you'll find a README doc for every single one, hopefully with a list of prereqs that you need to do to follow along, and then you can just do exactly what I did. So what's Tim saying here? Can we implement a scenario where we have one product API communicating another service that has 2 different versions? Yeah, absolutely. So that traffic management isn't just from the top level to the next level. You can have that going all the way down. So my website could talk to my products API, which could then have a traffic split at that level. Anything that has a Kubernetes service that I can model the host name as a destination. I can model that in Istio with my destination rules and my virtual service and control the traffic. And then Tim also says, can we let Istio route incoming traffic through that single product API, but then split it at that nested service? So yes, but you're not modeling that whole workflow. You're modeling the pieces of it. So what I'm saying is that here's my target. I'm going to split the traffic in this particular way. It doesn't matter whether it comes from this call or that call. So you're modeling it at the target service level. I hope that's answered your question. If it doesn't answer your question, go to eltons.show, which is where you'll find all the stuff. It's a terrible website. But I will make it look nicer one day. That's the homepage for the show. You'll see all the stuff here, all the links to all the episodes. If you go to eltons.show/AMA, then that will open you then you sign into GitHub, and then it will open a GitHub issue in that 6side ECS repo. People are asking me questions, and sometimes it's hard for me to make sure that I've got the answer for you. If you go to eltons.show/AMA, it will open the GitHub issue, and you can put in the details, and I will pick it up and answer it without any service level agreement. Okay, so that's all for this week. So next week, I'm going to finish off the talk about service meshes by talking about SMI, which is this abstraction, the service mesh interface that's trying to take the concepts of Istio and Linkerd and basically make them into something that's implementation independent. So you don't have these Istio custom resources in your application model. You have a higher level abstraction that may or may not be implemented by Istio or Linkerd. And there's an implementation of that which is called Open Service Mesh, and we'll look at those 2 things next week, and that will round off Service Mesh for this month. Oh yeah, so actually he's asked about Console. Again, Console is another service mesh. I'm not going to demonstrate it as part of this series. It works in a similar way, but Console is also a kind of service registry, and it has a kind of it ties in with the way that you register your services. So whereas with Istio, it relies on my Kubernetes service definitions, and it will pull the information from the Kubernetes API. Console kind of owns that service registration, service discovery, and service mesh. But I'm not going to get very far talking about that now. Okay, so I hope you found that useful. So join me again next week, same time, to talk about Open Service Mesh and the Service Mesh interface. And then that will round off our look at Service Mesh for this month. Thanks.